Hey everybody, today I'm back with another video. Today I'm going to be doing a separation of variables. I'm just going to be teaching you today, no FRQ, but so I've written out a little practice problem for us to do. This is just a worked example actually, and I'm going to be showing you how you would go through a separation of variables problem. And this can be both applied to Calculus AB and BC, so if you're in either of those classes, you'd want to stick around, watch the video, and see the process for this. So first things first, by the name of the concept is separation of variables. So you can understand that there's going to be some something's going to be separated. That's what I'm trying to get through. So now that let me get that, separation is the key here. And usually, just for some insider evidence, on the normal AP exams, I know that the 2020 exams are going on and you have these online 45-minute ones. But if we get back to normal, we're going to have exams that are they usually, the AB exam is almost confirmed to have some sort of a separation of variables FRQ. So make sure you keep that in mind when you do it, that this is very important. It's a very important concept. I'm sure it shows up on multiple choice, not only FRQs, but one FRQ usually involves this in some way or another. So it's important to know that you grasp this concept because it's a pretty big one in Calculus AB. It's a bit smaller in Calculus BC because there's so many more concepts that College Board has to try to focus on everything. But in AB, if you're taking it, definitely focus on it. BC, put some emphasis, but there's so many other things that separation of variables, still keep it in mind though. So what we're going to do, we're going to solve this problem right here, and here's what we're given. dy over dx is equal to, sorry about the alert guys, y over x squared, and we also know that y is equal to f of x, and that f of 9 is equal to 5. So basically, we know that there's a point, and what we're going to try to do in this problem is to try to solve for, f of x. This highlighter isn't as thick as I imagined. So we're going to try to solve for f of x. Or you could say we're going to try to solve for y. We're going to try to find an equation in terms of y. Now, we don't want any dy's or dx's in it. So we need to try to get those out of the way. Now, how are we going to do that? So, separation of variables, again, we're going to go to that. So what the first step of this process is, we're going to write the equal sign since there's still going to be two sides, is we're going to separate the variables. It says it in the name. So starting off, we're going to put all the y's on one side. We're going to put all the x's on the other side. Now you might notice that there's this function dy dx. Now what some people don't realize is that, so when we initially learn about differential calculus, we kind of see this dy dx as a kind of variable. We see it more of a variable as an actual fraction, and in reality it is a fraction. I'm sorry about the bad highlighting there, but it is an actual fraction, and so we can actually separate it like so. And so we want to keep all our dy's on the same side that we do y, and this is going to be 1 over y. Sorry, you miswrote it. And we're going to have 1 over x squared on the other side, since we're going to keep x's on this side, and dx. So now what do we do? Now that we have this, what can we do now? Well, we can actually integrate both sides. So if you take the integral of both sides, we write the equal sign. So now I just want to paste back a little, but what we did is we separated this fraction. That's all we did in this step. So nothing too much in this step. And remember, we're trying to solve for y, so we need to try to find a way to get rid of dy and dx, and then find y as a function of x. So let's do that. So what can we do first? And I said, you might have remembered that I said we need to integrate. So we're going to integrate both sides. And so we're going to have 1 over x squared. We're going to integrate that, and that is going to be minus x to the power minus 1 plus c. Don't forget the plus c. And we're going to do something special with the plus c. Well, not really that special. So, and then we have this side. We're going to integrate this. And keep in mind, it's in terms of y, so there's nothing weird going on here. So we have 1 over y dy. We're going to integrate this, and if you guys know, you know that this actually turns out to be ln, or sorry, natural log. It's the natural log of y. I'm going to put the plus c over here because I ran out of space. Just a second, I'm putting the plus c. And we don't know what these c's are. Keep in mind, these are just constants. We don't exactly know what they are. Could be anything. But what I'm going to do now is I'm going to move both of the c's to one side to kind of keep things a bit easier for us to write. So I'm going to move the c's. I'm going to also write this a bit better. Minus 1, and then we're going to put plus c here. Alright, and we have ln of y, natural log of y, I'm sorry. So now we have this expression. Now we could leave it like this, and we could solve for it, but that would be a little bit incomplete. We want a function of y, not a function of the natural log of y. So what we can do is, if you guys, by the way guys, I forgot to mention, if you guys ever feel like you know how to solve this problem, try it yourself, okay, and see if it matches up with the solution at the end. So we're going to continue on though. What I'm going to actually do is, I'm going to take both sides and I'm going to make them to the power of e, like so. So basically, we're going to have this. E to the power ln of y, or e to the power of natural log of y, and if you guys might notice an identity here, feel free to move on to the next step, and e to the power negative x to the power negative 1 plus c. That's what we have on both sides, and we're going to go right here. So now that we have this, we are going to you guys might have mentioned this just a few seconds earlier, that there's an identity right here. If you guys noticed it, it's actually that e to the power of the natural log. If you guys remember, the natural log of anything, we're going to put a here, just a random number, is equal to log base e. That's an e, I'm sorry, of that number. So these two are equivalent. That's okay, e. And so if you take e, and if you remember what this is the solution. I like to say solution. I don't know what term you guys use, but I use solution. This is the base. This is the base of an exponential function, and we have here the, oh sorry, not here. And so if we take e to the power, and keep in mind, what does a log like return? What does a log equal? It equals an exponent of this base. What it basically saying is e to the power of this value log ea, is equal to the exponent which you need. So in other terms, e to the power log e of A is equal to A. Now don't take this as a leap of faith. I'll probably cover this in greater detail in like another video, maybe about algebra. But for now, just keep in mind e to the power log e, or in this case, you can actually replace this with the natural log of A is going to be equal to A, and we can apply this right here. This cancels out, so we just have y. On this side right here, we can form another identity, not the same one, a different one. So we have, and this is a more, this has nothing to do with, this next identity has nothing to do with logs. I don't even know if they call them identities for this one. I know they're called that for trig, but I don't know about exponent. Are they called exponential identities? Comment down below. I don't know. But either way, so we have e to the power minus x to the power minus 1. That's what we have so far. You could write this as negative 1 over x if you want, but I'm just going to leave it like this. So if you guys know that, let's say we have something a, and I'm going to erase this stuff right here. Okay. Alright, so if we have something a to the power b plus c, then that's equal to a to the power b times a to the power c. So these are equivalent. We can perform the same thing here. E to the c. And if you guys, yeah, so that's what we have so far. Now we do have a function of y, but there's something we can do to make this even more simpler. If you've caught it already, this one is a bit harder to catch in my opinion. Not most people just skip it because you can, there's no point in it. I personally don't, because I find it a little easier to write that way. So what it is I'm just gonna move right here. So we're gonna have y is equal to, and we're gonna bring this e to the negative x to the power minus 1, and then times e to the c. So what's e to the c? And I'm actually gonna make a little more space here. Y is equal to, so e to the c, if you guys don't know, e is actually a constant. It's like 2.7 dot dot dot. I don't remember the rest of the digits. It's a constant number that it's an irrational number. But it is a constant. So a constant to the power of a constant is a constant. So we could just label this as just one big C, which we can put in front of here. And I'm sorry, erase this C that I put right here. And this is what we have. So obviously, as you can see, what I did with the C's is I kept on combining them, and and sometimes to keep track of them, you can put like little subscripts like C1, C2. I personally don't do that because in the end, this C right here is really the only one that College Board cares about. As long as you're putting C, College Board doesn't care. Maybe your teacher thinks differently, but College Board does not care what if you put a subscript for C. As long as you're putting C in some form, like here, that's all they care about. And so now that we know this, C, we can't just have C in our equation. We wanted y as a function of x. We can't have this other variable right here. So we have to find a way to solve for C. Luckily, we have this point right here. We're going to plug in that point. And we are going to get C, because we don't know what that is yet, C to the minus 9 minus 1. Alright, so this is going to be CE to the minus 1/9. I'm sorry that the exponents look so bad. And then 5, and then you can divide this. Okay. And you're actually if you guys know about the exponent rules for a negative exponent, I divided this and brought it here, and then I'm just going to have it right here, and this is going to be c, what we're not done. Remember, we wanted a function of x, so we're going to plug this constant back in here, and you will have your solution. Thanks for watching.